Nike sneakers are some of the most recognizable products on the planet, worn by professional athletes, casual runners, and everyday consumers across nearly every country. Yet behind every finished shoe is a massive, highly coordinated industrial manufacturing system that blends material science, precision engineering, automation, and skilled human labor. What looks like a lightweight, flexible sneaker is actually the result of hundreds of components coming together through tightly controlled processes designed to deliver comfort, durability, performance, and visual consistency at enormous scale. And today on The How Factory, we're going inside modern footwear factories to see exactly how Nike sneakers are mass-produced, from raw materials to the finished pair boxed and shipped worldwide. The process begins with materials sourcing, long before a shoe ever takes shape. Nike sneakers are built from a wide mix of components, including engineered mesh fabrics, synthetic leathers, foam compounds, rubber outsoles, thermoplastic reinforcements, adhesives, and molded plastics. These materials arrive at factories from specialized suppliers around the world. Rolls of textile fabric come tightly wound and wrapped to prevent contamination. Rubber compounds arrive in slabs or pellets. Foam materials used for midsoles, such as EVA or proprietary cushioning blends, are delivered in raw form ready for molding. Every incoming material undergoes inspection for thickness, density, elasticity, color accuracy, and defect tolerance. Even slight inconsistencies can affect fit, comfort, or performance, so quality control begins at the loading dock. One of the first major stages is upper production, the creation of the shoe's fabric body. Modern Nike sneakers often use engineered mesh or knit uppers designed for breathability and flexibility. In textile departments, computerized knitting machines or automated weaving looms produce fabric panels with varying density zones. Some areas are tightly woven for support, while others remain open for airflow. These machines follow digital patterns down to the stitch level, allowing designers to control how the shoe flexes during movement. For cut and sew uppers, large fabric sheets move into CNC cutting machines, where oscillating blades or laser cutters slice panels with extreme precision. Each panel corresponds to a specific part of the shoe: toe box, midfoot, heel counter, tongue, or collar lining. Once cut, upper components move to assembly lines. Here, heat presses bond reinforcement layers to high-stress areas like the eyelets or heel. Synthetic leather overlays may be added for structure. Logos, swooshes, and branding elements are applied using heat transfer films, or stitched directly into the upper. In some models, welded seams replace traditional stitching to reduce weight and eliminate pressure points. Industrial heat presses activate adhesives that permanently fuse layers together. At this stage, the upper still lies flat, resembling a complex fabric puzzle rather than a shoe. While uppers are being built, sole components are manufactured in parallel. The outsole, the bottom layer that contacts the ground, is typically made from durable rubber compounds. Rubber pellets or slabs are fed into molding machines where heat and pressure form them into patterned outsoles. The tread design, traction zones, and flex grooves are molded directly into the rubber. Each outsole is cooled, trimmed, and inspected for uniform thickness and surface defects. For performance models, different rubber densities may be combined to balance grip and durability. Above the outsole sits the midsole, the cushioning heart of the sneaker. Midsoles are usually made from foam compounds designed to absorb impact and return energy. Raw foam materials are injected or compression molded into midsole shapes using steel molds. These molds define not only the silhouette of the shoe but also internal geometry that affects cushioning response. Some midsoles incorporate air units, gel systems, or layered foam constructions. Air units are manufactured separately by sealing pressurized gas inside tough plastic membranes, then tested for leaks before being embedded into the midsole. Once molded, midsoles are cured, trimmed, and checked for density and rebound performance. Next comes one of the most critical stages: lasting. This is where the flat upper becomes a three-dimensional shoe shape. The upper is pulled over a foot-shaped mold called a last. Machines or skilled workers stretch the material evenly around the last, securing it temporarily underneath. This process defines the shoe's fit, toe shape, and volume. Wrinkles or misalignment at this stage can ruin the final product, so precision is essential. Adhesives are applied to the bottom edges of the upper in preparation for sole attachment. Once lasted, the upper meets the sole. Adhesive bonding is the most common method in modern sneaker production. Both the bottom of the upper and the top of the midsole are coated with specialized industrial adhesives. These adhesives are carefully formulated to remain flexible while maintaining long-term strength. After application, parts pass through heat activation tunnels that prepare the adhesive for bonding. The upper and midsole are then pressed together using hydraulic or pneumatic presses that apply uniform pressure. In some designs, stitching is added around the sole edge for additional reinforcement and style. After sole attachment, the shoe moves to curing racks. Adhesives require controlled time and temperature to reach full strength. Shoes rest on racks for hours or even days depending on the materials used. During this time, inspectors check alignment, sole symmetry, and bonding quality. Any separation, unevenness, or cosmetic flaw can send the shoe back for rework or rejection. Next, the shoe enters finishing and detailing. Excess adhesive is cleaned from seams. Edges are trimmed. Insoles, often made from foam or molded footbeds, are inserted. Laces are added. Tongues are adjusted. Size labels, country of origin markings, and compliance tags are attached. For performance models, additional components like stability plates or heel counters may be installed internally before final closure. At this point, the sneaker looks complete, but it still must pass testing. Quality control teams perform visual inspections, flex tests, and dimensional checks. Random samples undergo mechanical testing, where machines repeatedly bend the shoe to simulate thousands of steps. Outsole abrasion tests measure wear resistance. Cushioning is tested for compression and rebound. Fit consistency is verified using standardized measurement tools. Any batch showing abnormal results is isolated and investigated. Once approved, sneakers move to cleaning and preparation for packaging. Shoes are wiped down to remove dust or residue. Tissue paper is inserted to maintain shape. Each shoe is paired with its mate and placed into a branded box along with spare laces or inserts if required. Boxes are labeled with model number, size, colorway, and barcode information. Automated scanners verify that box contents match the label exactly. Packaging lines then group individual boxes into larger cartons. These cartons are stacked onto pallets by robotic systems optimized for stability and space efficiency. Stretch wrap secures the pallets for transport. Throughout this stage, warehouse management systems track every unit using digital inventory controls. Each pallet can be traced back to a specific factory, production line, and date. Behind the scenes, logistics coordination keeps everything moving. Nike operates a global supply chain, with factories often located near material suppliers and shipping hubs. Finished sneakers are transported by truck, ship, or air freight to regional distribution centers. From there, they move to retail stores, online fulfillment centers, and partners worldwide. Timing is critical, especially for new releases tied to marketing campaigns or athletic seasons. Sustainability also plays an increasing role in modern sneaker manufacturing. Factories work to reduce material waste by optimizing cutting patterns. Scrap foam and rubber are collected and recycled where possible. Water-based adhesives replace solvent-based ones in many models. Energy-efficient machinery and LED lighting reduce power consumption. Some Nike sneakers incorporate recycled plastics or sustainable textiles, requiring additional sorting and material handling steps within the factory. What makes Nike sneaker manufacturing remarkable is the balance between scale and precision. These factories produce tens of thousands of shoes per day, yet each pair must meet exact standards for fit, comfort, and appearance. A shoe must feel identical whether it's bought in New York, Tokyo, or Paris. Achieving that consistency requires not only advanced machinery, but also trained workers, digital process control, and constant monitoring. From engineered fabrics and molded foam to adhesive bonding, lasting, testing, and packaging, the journey of a Nike sneaker is far more complex than most people imagine. It's a system built on material science, biomechanics, automation, and logistics, all working together to turn raw materials into performance footwear worn by millions. And that is exactly how Nike sneakers are mass-produced in modern factories: cut, molded, assembled, bonded, tested, boxed, and shipped at global scale through a finely tuned industrial process hidden behind one of the world's most iconic products. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines and systems behind everyday products.